Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. So in this video, I would like to discuss about subtopic 1.3, the inclusion and also exclusion principle. So the aim of this subtopic is, at the end of the lesson, I want everybody should be able to find the number of ways to do one of the two tasks by the inclusion and also exclusion principle. Okay, so let's start with the introduction first. So when two tasks can be done at the same time, we cannot use the sum rule to count the number of ways to do one of the two tasks. Why? Because adding the number of ways to do each task lead and overcount, since the ways to do both tasks are counted twice. So what we do, to correctly count the number of ways to do one of the two tasks, we add the number of ways to do each of the two tasks, and then we subtract the number of ways to do both tasks. So, alright, let's consider two finite sets A and also B to count the number of elements in A union B. We first count the the number of elements in A, and then we add the number of elements in B. However, the elements that are common to A and B are counted twice in this process. To overcome this problem, we must subtract the common elements of A and also B in order to determine the number of elements in A union B. So this process is called inclusion-exclusion principle for two finite sets. So this is the formula. A union B is equal to element A plus element B minus intersection A and also B. This also can be visualized from the Venn diagram as shown in this picture. So this is element A and this is element B. Since A and B have the same element, so it becomes A intersection with B. Okay, so how to get the value for A union B? So we need to subtract the element A intersection B. Actually, from two finite sets, it also can be extended to the inclusion-exclusion principle for three finite sets. So, since we have three finite sets, the formula is a little bit complicated. So, this is the formula. Okay, it's longer from the two finite sets, where A, B, and C are finite sets. So, this is element A, element B, and element C. Okay, and this is intersection between A and B. This is intersection A and C. This is intersection B and C. And at the middle, this is intersection for A, B, and C. So if we go to the formula to get the union A, B, C is equal to element A plus element B plus element C, then subtract element A intersect with B, subtract element A intersect with C, subtract element B intersect with C, and lastly, we need to add element A intersect B intersect C. So, alright guys, for better understanding, let's try some example. So now, this is example 1. How many bit strings of length 5 either start with 1 bit or end with 2 bits 0, 0? Okay, so what is a bit string? Okay, bit string is a number that starts at the 0 or 1 only. Then we want to construct a bit string of length 5. That means 1, 2, 3, 4, 5. So, and we also have a condition. Okay, the first condition, okay, it starts with a 1 bit. So, first condition, first place must be 1 only. And then, or the second condition, okay, the bit string must be end with 0, 0. That means 1, 2, 3, 4, 5. The last two must be end with 0, 0. Okay, for the first one. Okay, so since the first place must be start with 1, so the second place it can be 0 or 1. Okay, since it can be repeated, so that means the third place also it can be 0 or 1. The fourth place 0 and 1. The fifth place also 0 or 1. So total you will have 1 times 2 times 2 times 2 times 2, you will have 16. So this is for the first one. Now, we go to the second one. Second one, the last condition must be 0. The last two condition, the last two place must be 0. So, the first place, okay, it can start with 0 or 1. Second place also 0 or 1. The third place also 0 or 1. So, the total is we have 2 times 2 times 2 times 1 times 1. So, we have 8. Okay, if we think clearly, answer from the first one and answer from the second one might be same. Okay, so that's why, okay, let's say this is for A and this is for B. That's mean work from A and work from B may be same. So how to find the same thing? Okay, so again we write we have 5 place 1 2 3 4 5. Okay, let's say it start with 1 and at the end we start with 0 0. Okay, so in the middle we have 0 or 1, 0 or 1. Okay, so the total is 1 times 2 times 2 times 1 times 1, we have 4. So for this thing, it become A intersects with B. So how to find the A union B? So by using the formula, A union B is equal to element A plus element B minus element A intersect with B. So we have element A 16, element B 8, element A intersect with B, we have 4. So total we have 20. Alright, so now let's try example number 2. So a computer company received 350 applicants from computer graduates for a job planning in line of new web servers. Suppose that 220 majored in computer science, 140 majored in business, while another 51 majored both in computer science and also business. So how many of these applicants majored neither in computer science nor in business? Okay, so let's list down all the information that we have. So total application, okay, we have 350, where 220 majored in computer science, 140 majored in business, while 51 majored in both. So we are going to find, okay, application that not in computer science and nor in business. Okay, by using the formula, so the formula is A union B is equal to element A plus element B minus element A intersects with B. So, for this one, computer science, will be element A. For 140 for business, this will be element B. And for both 51 application, this is for element A intersects with B. So, apply all this information to this formula, we can find the value for A union B. So, let's apply 220 plus 140 minus with 51. So, A union B is equal to 309. But that is not our final answer. our final answer is we want to find how many applications that not in computer science and also business. So the final answer is the total application 350 minus with the application that from computer science and business, that is 309. So the application that not computer science and also business is equal to 41. So alright guys, let's try another example. Example number 3. So let P be the set of the integers that are less or equal 20 and multiples of 4, while Q be the set of the integers that are less or equal 20 and multiples of 5. Determine the number of distinct elements in P union Q. Okay, so let's list down the information that we have. So P, the condition is less or equal 20 and must be multiple of 4. That means element of P is equal to 4, 8, 12, 16, and also 20. And then Q. Okay, it must be integers that are less or equal 20 and multiples of 5. That means the element of Q is 5, 10, 15, and also 20. Okay, so from here, if we compare element P and also element Q, okay, we can find we have a same element. So what is the same element? 20. So 20 will become element P intersect with Q. So that is 20. Okay, so by using the formula, A union B is equal to element A plus element B minus element A intersect with B. So element A, this is for P, so total we have 5. Element B, this is for Q, total we have 4. And element A intersects with B, this is P intersect with Q, that is we have 1 element. So total is equal to 8. So I hope everybody can understand all my explanation about subtopic 1.3, the inclusion exclusion principle. Okay, so study hard, all the best, and thank you guys. Assalamualaikum.